42% of adults over 55 will develop dementia by age 95. That number comes from research published in a major medical journal, and it describes a trajectory that is getting worse rather than better. Projected new cases are expected to double from roughly 514,000 in 2020 to 1 million by 2060. Dr. Mercola's analysis focuses on why the brain is specifically and disproportionately vulnerable to the cellular energy failures that drive this epidemic, and what can be done to change that trajectory before the damage accumulates beyond recovery.
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello and welcome to Dr. Mercola's Cellular Wisdom.
The energy demands of the brain are unlike those of any other organ. A single resting cortical neuron, a brain cell at rest, doing nothing more than maintaining its baseline state, requires approximately 4.7 billion ATP molecules every second. That is not a number for an active, firing neuron. That is baseline maintenance. The brain's continuous and extraordinary energy demand makes it the organ most sensitive to even partial failures in mitochondrial function. When the cellular structures that generate ATP are compromised, the brain is the first to show it.
Mitochondrial dysfunction begins at the structural level. Healthy mitochondria maintain an elongated shape that facilitates efficient electron transfer through the metabolic chain that generates energy. When mitochondria are damaged by oxidative stress, by excess linoleic acid from seed oils incorporated into their membranes, or by chronic nutrient insufficiency, they lose this efficient morphology. Electrons begin to escape the electron transport chain before completing the full energy-generating process. Those escaped electrons react with oxygen to form reactive oxygen species, which then damage proteins, DNA, and the mitochondrial membranes themselves, creating a self-reinforcing cycle of decline.
The calcium buffer failure represents one of the most consequential downstream events. In a healthy cell, mitochondria actively absorb and buffer excess calcium, preventing it from reaching concentrations that trigger cell death. When mitochondrial function deteriorates enough, this calcium buffering capacity collapses. Calcium floods the cell interior, triggering the opening of a structure called the mitochondrial permeability transition pore, a channel that, once opened, releases additional destructive signals into the cell. The result is widespread neuron death in areas of the brain where mitochondria are already under stress. Dr. Mercola notes that this mechanism is visible in the neurodegenerative changes associated with multiple brain disorders.
The research connection to lifestyle inputs is direct. Linoleic acid from seed oils is particularly damaging to mitochondria because it incorporates into mitochondrial membranes and oxidizes more readily than saturated or monounsaturated fats. Once oxidized within the membrane, it disrupts the precise structural conditions the electron transport chain needs to function efficiently. This is one of the specific pathways through which the dietary fat environment people have been told is healthy for 50 years has been degrading the brain structures that people depend on for cognition, memory, and coordination.
The protective strategies Dr. Mercola identifies work at multiple levels of the pathway. Eliminating seed oils removes the primary dietary source of membrane-disrupting oxidizable fat from the mitochondrial environment. Optimizing carbohydrate intake ensures mitochondria have the metabolic substrate they depend on for ATP generation. Reducing environmental toxin exposure through filtered water, organic food, and reduced plastic contact lowers the ongoing chemical burden that adds to mitochondrial stress. Consistent sunlight exposure supports cellular energy through its effects on the electron transport chain directly. Boosting NAD+ levels through targeted supplementation provides a critical cofactor that mitochondria require for electron transfer.
The timeline matters here. Neurodegeneration is not a sudden event. It is the accumulated result of decades of compromised mitochondrial function. In an environment that consistently fails to support the energy demands the brain makes every second of every day. The interventions that protect brain cells most effectively are the ones implemented early. before the cellular energy environment has degraded to the point where the calcium buffering fails and the permeability transition pore begins opening regularly. Dr. Mercola's position is that waiting for cognitive symptoms is waiting too long, because the structural damage that produces those symptoms has typically been accumulating for years before they appear.
Here's the question worth sitting with. How much of what you eat daily is actively degrading the mitochondria your brain depends on? And have you made any changes specifically with long-term cognitive protection in mind? Drop a comment and tell us where you are in that process. Thank you for listening to Dr. Mercola's Cellular Wisdom. See you in the next episode.
Looking for trusted health wisdom you can hold in your hands? Discover the life-changing books of Dr. Mercola at joyhousepublishing.com. These titles bring decades of natural health research into practical steps for better energy, stronger immunity, and clearer thinking. Take charge of your health with guidance rooted in science and experience. Visit joyhousepublishing.com now and claim your bonuses while they are available.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.